Hello,
Good
everybody.
morning.
Good morning, Achim. Now we are the
Good
guys
morning,
from
Frank.
Germany trying to solve day 10 of Advent of Code. 30 seconds to go. Let's see what today's puzzle will give us.
Yeah, let's see.
10 seconds.
And open. Oh, cathode ray tube. You avoid the ropes, plunge into the river, and swim to shore. Yeah, it's something about meeting back up with them upriver, but the river is too loud and to tell exactly what they're
So,
saying.
CPU simulation. Two instructions.
Yoo-hoo!
Your puzzle input is instructions to program. So,
Yeah,
let's see what the actual question is in the end. What is the sum of these six signal strengths? Okay. But there are a lot of definition of cycles and signals.
yeah. I think I ripped some code over from 2016,
Oh,
where an assembly computer was created.
I would not like to search for that old code.
That why that class has a proper name. They know I did something like that.
He gives you a
Closing the
small example, which is like a big example. It's try to copy it. No, I copied it. It's not so small. Okay, now let's copy the puzzle input also.
what can this thing do? Has a
Well,
single register, okay, with name X.
well, it's only two commands, so it can't do too much.
Yeah, I know. This is far more powerful than need to be, but I have the general operations here. And I believe there might come a variant which has more registers. And XV and no op. Oh, this is operations that take multiple cycles. Delayed ops. Facet.
Okay, we need to count the cycles, in which cycle we are.
Yes, yes. And I think it's important that AdX probably, if no op is issued, the computer probably runs one cycle. But if you run AdX, it just registers the command. That I believe that might be very necessary for the solution. Wait, this is different. Okay. These things doesn't operate in parallel. They just eat time.
Yeah, there's no parallelism. Just register cycles, chuck, 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 one after the other. And you need to count the cycles, and once it reaches the barrier of 20, then you need to increment your answer by the current value somehow. So it's not the right answer. So I just committed an answer, but this was not correct. So I need to reread again how it works. It's at the start of the... Okay. At the start of the 20 cycle. It's okay, at the start of the 20 cycle. Maybe this works better. It's actually still the example input. Oh no. Okay. So how in this example it first takes the first value at the 20th cycle and the second at the 60th cycle. How comes this 20, 60, 100? Where is this plus 40 or where comes this from?
That's just a constraint from the task.
Is
It
this,
just wants the 20s, 60s, 100s, 140s, 180s, and 220s
okay.
cycle.
These are fixed values or how does this work?
If you can go to the bottom, find the signal threads during the 20th, 60th, 100th.
Yeah, okay, I get it. Thanks. It's simply that it's these numbers. Yeah.
That's just per order mufti.
So I get closer. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2021. Okay. Where is it? It reminds a little bit of the yesterday's riddle where there is no exact description of how the simulation works, but instead there are some funny examples. So for example, the first increment is 420 because it's 20 times 21. And in my program it's still 20 times 20, and now I have to find why it's 21 and not 20, and there's no paragraph stating this how it works actually.
180, 220.
So during the 20th cycle register X has the value 21. With my code it has the value 20, so there's something wrong. So X starts at 1.
Yes, it starts at 1.
So it's 1 too less in my code.
Run. That isn't right.
So the cycle starts at 0 or at 1? The first cycle is 1, isn't it?
Oh, the signal strength multiplies.
Yeah. So my x is still 1 too small at some point. So this add instruction also works like this.
Wait, no. It multiplies with the cycle count.
Yeah.
Didn't notice that.
So for me this works, but I have sometimes the wrong value for the x. So it seems to matter if you take it before incrementing the count or after it, or somehow here the mechanics is wrong with my code. Still wrong. So now it's wrong in the last of the 6. No, that's again. It reminds me of yesterday because now it's trial and error how to figure out how this could be meant to work here, and this is yeah. Well,
And
let's
again, I
phrase it like
produced
this. I don't like it. I like it.
I again produced a pretty annoying string concatenation. But this needs to be a plus. And then... Damn it, for the sample data I'm off by some 200 points. So...
1.
This cycle is right. 100 cycle is right. 140 cycle is right. 180th cycle is right.
This.
But why doesn't the 220th cycle add up?
Yeah, that's wrong with my code too. So I guess this is.
The example says that the 220th cycle has to deliver 3,960, and I got 4,180.
Yeah, exactly, because x is 19 and should be 18. So now why is this? What's the rule to get the right result here? Now I got the right result with my example code. Now I try it on the read. So I guess it is we need to check if the add instruction has 2 cycles. So we first need to check if with the next instruction the 220 is reached, and then if yes, take the old value, and then after that we need to increment the value, and if the counter then matches the 220, we need to take the new value, and this 220th cycle is exactly between such two instructions. It's such a middle instruction, and here you need to actually take the old value or the new one. I need to care for my code. Something is wrong here. Why is this? Ah, okay.
I think I got it by putting out by adding a debug information after every instruction. And I believe that the instruction for the 2019 and there's an instruction starting at the 200 and after the 218th cycle where the register has value 18. It must be an add operation, an addx1 or something like that. And it goes through the operation, 2 steps, and I add it before I raise. I believe you add the cycle counter and check for the update, and then you have to edit.
Yeah, it's a bit weird how the add and count instruction works. Yeah.
I will try that.
Do that, yes.
And now I get to the 13,140. That was it. And it is sufficient for solving the first part.
That's nice. Now we have to.
But that thing was ugly.
Now we have to draw a picture here. So this CPU gets connected to a CRT, and it has a weird mechanic how it draws the pixels.
Okay, so we are doing something different now. What's the horizon?
Okay. On each cycle. So next.
Okay. So kick out the debug information. Oh, I think I get it.
I did not understood how this x for which x value is a pixel on and when it's off. So okay, there's a position on the screen, and then the left and right pixels are on, and then we need to synchronize this with the cycle.
In each cycle, the thing checks where the sprite position is, and if the sprite position is near the point where the CRT wants to draw something, it draws an hash, and if it isn't, it draws a point.
Yeah.
Do cycle.
My computer becomes slower and slower. My console behaves like this CRT output a little bit. It's pixel by pixel. This is something I hate about the C compiler. There's a simple bug somewhere, error, syntactic error, and then it gives like tons of lines of error output, and you have to scroll like 1000 lines up to see the original error in the error output. This is really weird on a GCC. I try to stop this with some command line options to the GCC option, but it does not work for me. So it doesn't work as expected. Why is this?
Not for me as well. Oh, I do the increment too early.
It's not exits on as X E.
That looks more like it. And you get a passcode.
And does it work?
EGJB
Oh.
G C
If it looks like a
F
code, it
K.
most likely works.
And yeah, it worked.
Great. So I got currently 40 seconds to run once compile and run needs 40 seconds.
Boah.
This video software really slows down everything.
Why does it take so many time to compile?
So, and it still does not work. So I can share my screen if you want to watch.
You can do that.
I try. It needs some seconds until the window pops off on. So now you maybe can see it. So just to explain, I got here an array called INSX where I write the values of the X register for all cycles. So this is filled with the X values. Then afterwards I'm iterating this INSX thing and try to draw the sprites in the thing here. So I goes from 1 to 220, and then
Mm-hmm.
so this is the line is I divided by 40, and the column is I mod 40. So and then the condition is if this x value at the cycle I was bigger or equal to I minus 1, and it's smaller than I plus 1, smaller or equals,
I
then
have the same if.
then it should be on this pixel. So I switch it on like this. So I initialize all of them with a dot. And actually it looks like this, but only in the first line I got some pixels. In the other line I don't have pixels for some reason. Now maybe I just output my RNSX. Maybe this is wrong. RNSX. Do it like this. E. Okay. So just to be sure that there's no all zero values or something like this. So this should be right. I'm not really sure with this 1 to 220, or should it be 0 to
I
229.
believe I start at cycle count 0.
So it will be I minus 1 here. So, but this would not explain my result because it actually draws only something in the first line, and it should be shifted by 1 pixel everything. This is no. But it could be with this. Then let's simply try the 0. This is simpler. And let's stick with the I here. So let's see what this gives. You see here, this was the output from previous run. Now I got an error here, RNSI. RNSX. I wanted to output the X here. So since there are pixels set in the bottom line, there should be some values in the last thing. So here, okay. But you see this? For
Yeah,
some
that is
reason
completely off.
these values are not correct here. Also there is a minus 1, which does not look too good. Why is this?
As if the diff operation always scores 0.
The diff operation? What's the diff operation?
You have a diff and a mod.
Divide, okay. Yeah. I goes to try 220 and it's simply that my x value, you saw that the x values are fairly slow. They are all low. They are all below 100. So, or all below 40. I Here, look this last line. They are all kind small
Yeah.
value, and it checks if the x, this value, the 7, is between 208 and 210. And so if it's not, the pixel is not drawn. So it, because these values are fairly small, it draws only pixels in this line
Um,
above. Is this the
m- Maybe you should add II and JJ to your debug
okay?
output.
No, these are right. I the
They
problem
should be
is,
right. Yes, I know, but
no, you see that it does not draw the pixel because the x value is too small. It correctly draws no pixel, but the x value, do I have to add something here to this x value? For example, the line value or something like this, because they are all smaller than 40. This makes sense. Know what I mean?
um,
Like plus II, something like this.
you are comparing the x value with your loop variable.
Yeah, exactly.
But that's not. But you need to compare it with the position of the cathode ray in that line.
Only in that
So
line,
you need
yeah.
to
Okay.
compare it with JJ. The question
Yeah,
is
okay.
JJ at or near the sprite?
Okay. So then it should be
And you forgot, and you dropped out the -1 and +1.
okay.
They are important.
Yeah, yeah, yeah. Just let's have a look if this looks better. Okay. So
Okay, that is
minus one.
that is not completely off.
Yeah, there are some pixels missing because of the minus and plus one. Only the ones where it's exactly where drawn now. Now it should draw all, I guess. Well, still somehow shifted. Or it looks like
But at
somehow
least you get
shifted.
some pixels.
So how could it be shifted now? Maybe it's still 1 to 220 because it's so organized in my ANSX vector. No, it's not. Some shift in there. So
You are currently processing the real data or the test data?
I hope the real data.
Because it helped me a lot processing the test data.
Trying the test data, okay. You copy the test data. So we would now see if at least the first line is correct or something like this. So even the first line is wrong.
Yes.
This seems to be completely off. Somehow.
Looks like that.
So X starts at 1 for some reason.
Yes.
Cycle.
C is your cycle.
Yeah, C is my cycle. So C.
I start that at 0.
Yeah, well, you can do this.
I start that at 0, and the first and only the operations increment that.
Yeah, I started at 1 because the first cycle is the first cycle and not the zeroth cycle. But you can do both. That's my point. It's just where
Okay.
you increment and where you check. So if you start at 1, you have to first check and then increment, and if you start at 0, you have to first increment and then check. So this must correspond, but it does because it worked in the first star. So, and also, if it would be wrong, it would be simply shift everything by one position. So we can adjust it here by starting at 0 or starting at 1. Or whereby, it's not true. So if we use IDX here, it might be work otherwise. So this would shift everything by 1 pixel. But it's still, but most of them are correct. This puzzles me a bit. There's so
Yes,
much.
but the first line is 2 hashes, 2 dots,
Yeah,
and
now it works. Look.
that looks
Yeah,
better. That
better,
looks a
but it
lot
not
better.
complete. Here's something missing. Why is this?
Don't know.
How could this be? That there's something. Is 220 to not enough? Does it be 260?
Um, I believe it's 240 or something.
220
You,
plus
you,
40 would
you
be
have a
260.
display, or you have a display with 40 pixels on
Ah,
width
6
and
times
6
40.
pixels height.
Okay,
So
6
you,
times 40
you
is
have
240.
240 to cover.
Okay, understood. Yeah, looks better. So, CP, clipboard, input, dtnb.test, yay. So now this will output the answer. So it's P set G P K P E B. You, we are the greatest. Achim, I thank you. Let's have a look at the stats here. So 5,000
I,
people. So second star on position 5,000, but first star at least was better today for me.
I haven't looked at the stats yet. So for me, part 1 rank 5,800 and part 2 3,500.
So
Solution time 27 minutes and another 11 for part 2.
so for me looks more or less similar. First star 23 minutes and the second star was kind of slower 52 minutes. Yeah. Well, not so bad like yesterday, but again such a simulation with more or less weird rules. So
If you are interested, I could go through, I could explain my solution for that.
yeah, then share. Wait a moment, I will rearrange my video so this is on the video.
Yeah, take your time. I'm activating the share now. Share has been activated.
Now this should be visible here. Yeah. Just tell us.
So, the Riddle class itself doesn't have that much code. And for part 2, I didn't throw in some additionals, so I could just kill that. And the magic is here in the Elf CPU class. I ripped that off from the Assembunny computer from 2016
Okay.
because I had the impression, oh, that might be somewhat similar. It's not so much. So for the execution method, after parsing the statements, there's some code down here identifying them. Parsing through the statement, if it's a no-op statement, the cycle increment, and then if that cycle is relevant for part 1, signal strength sum up, I call that thing that takes the register value, multiplies it with the cycles, and sums it up for the output below here or here. For part 2, I replace these increments. So after each cycle increment, I would check for the relevant interrupts for part 1. I replaced the simple increment instruction with a new method, and on the first attempt, this increment was up here, and the picture was wrong. So I switched it, put it down here, and what I do every time it does the cycle, I'm writing as a character onto the screen.
Yeah.
So I don't need to worry about line arrangement. Well, I somewhat do. If the draw position would be 0, I would go to a new line.
Yeah, it's pretty straightforward. So making the mechanics of the simulation correct, then it simply gives the right output. So for me the biggest challenge or one of the big challenges again was to read all the rules in the text, because the text is so clumsy again in this riddle text, and so much examples and so much text, how to find the right information in the right places.
For writing the passcode into the solution, I should have marked it, because then you can read the letters a bit better.
Yeah, it depends on your display colors and things. Yeah,
I have black characters on white, and that's a little bit more difficult to identify.
Yeah.
But I got a solution. Yeah.
So today it's kind of advantage. No, how is the word for unentschieden?
Draw.
A draw. Yeah, a draw between us. Yeah. Okay. Tomorrow, same time, same place.
Yes. That's all, folks.
So have a nice day. Goodbye.